Welcome to Moonscapes, everyone, for June the 24th, 2015. It is about 8:40 in the evening, just a little after sunset. And this is going to be Moonscapes number 34. I missed last month. I was with my son up in Vermont. We were doing some prospecting for gold, learning how to pan gold. Another little fun thing to do, and actually got quite a bit. My son did fairly well. I didn't do too bad myself, and we had a good time. But anyway, it kind of messed me up for videoing last month. So this is the first video I've put up in about a month or so. Tonight we are using the 10-inch. That is my Schmidt Newtonian 10-inch Mead. It's got the corrector plate up in front. Light comes through the corrector plate down to the 10-inch mirror at the bottom, which is concave, sends it back up to the secondary, which is mounted on that corrector plate, and sends the image outside the eyepiece. I have mounted in there tonight a 2X Barlow and a 4.5 millimeter eyepiece. That is giving us, without any zoom, 376 power. Right now we're looking at the Alpine Valley area of the moon. That's that cut to the mountain range over there on the left-hand side of the image. This is more of an experiment. I think a number of times I've talked about trying to pick up the craters in the floor of Plato, the little crater pits that are just about a mile across. I don't know how successful. I don't know what that jumping around is out there. Something almost looks like a bird or something landed on the telescope. The telescope really jumped. I don't know why. I've got the telescope set up on a permanent pier at my son's place, about a quarter of a mile from my house. The pier, it's only a 4x4. I really should have tripled it up or even put 4x4s nailed together and then mounted the mounting plate on top of that. It would have made for a much sturdier mount, but for the moon and lower powers, it's pretty good, and we'll see how it does with this high power. Now, tonight, as I said, I wanted to go after, and unfortunately we're not going to be able to go after Plato. See that little C-shaped object that's just about dead center in the screen? That is the ridge of the crater Plato, and as you can see, it is not sunrise on the floor yet. If we wanted to stay with it for about maybe 3 hours, we could probably get sunrise on the floor of Plato, but the location I'm working from is not going to allow that. One bad thing about this setup here is the tree line to my west is very, very high, so we won't have that much time. But let's zoom up and see how large the image would be with this. And we're about 3/4 of the way. Look at that wall of Plato. It's really interesting, but unfortunately we can't see into the floor itself. We're fairly close here. Now, there's one problem using this 10-inch as opposed to the 5-inch Schmidt, well, it's not, actually it's not a Schmidt, it's the Maksudov Cassegrain 5-inch, which it's only half the size diameter-wise, but it's a longer focal length and gives me much higher power. This 10-inch is using it straight without the Barlow lenses in f4. In other words, it's only a 40-inch focal length. It's low power. It's made for wide field viewing and wide field imaging, which I do quite a bit of. Let's go back over onto the Alpine Valley there for now. So it's tough to really drive this thing up to a higher power. Now, I could put a 3X Barlow in here and even a 5X, but as you can see, even with a 2X, we've got a fairly nice view, and fairly close in. And if we got a real steady night, we would have a shot at picking up those crater pits. Now, one thing I like about this view, look at the Alpine Valley dead center, and then to the left of that, going towards 9 o'clock, look at the shadows of that mountain range. That's the lower end of the Apennine mountain range that curls around, and the Alpine Valley cuts right through it. Look at those sharp shadow points. You only get that when the sun angle is very low, and sunrise has just occurred there within the last 24 hours, probably even less than that, because you can see right there again is Plato, and it's right on the terminator. So the Alpine Valley and the associated mountain range here is just a very short way away from the terminator, so it's got a very low sun angle, which is really nice. Let's kind of just zoom along here. Look at some detail along the terminator. Now here's Archimedes. This is another crater that's got flat floor. This also has crater pits in it, and this one would be a good test. But notice how soft the image is going right now. We're almost look like we're losing focus, but that's seen because I had real sharp focus when I started the video, and it looks like it's gone soft. I could go in and let's see what happens if I put the auto. That's not where I want to be. Yeah, it is. That's the white balance. Why is that? That's not where I want to be. I want to be over on this one. There, and put on autofocus. Okay, autofocus is on now. And let's see what that does. That may cause the image to jump around a little bit, but this is a drawback of trying to use really high powers. It'll muddy up the images. If I were to put a lower power eyepiece in there, we get a much cleaner image. But as you can see, let me zoom in on this crater. Let's center it up a little better. Okay, that's about dead center, so when we zoom, it should kind of home right in on the crater. And as you can see, we're not going to get to see anything on the floor of that crater. The scene is just too muddied. Yeah, so my experiment would fail tonight also. But I wanted to give it a try. I haven't used the 10-inch in a while. One thing about using the 10-inch, now that my son has this place, I can leave this tube assembly here. I don't have to pack it up in a car and take it home with me. I leave it in my son's basement, so I have a choice between the 5-inch and the 10-inch when I do the videos. And that's pretty handy. It makes it a lot better. Let's zoom up along the terminator here. There's the Alpine Valley, left side above Archimedes. The Alpine Mountains, the Apennine Mountains, I mean, they're really impressive tonight. Look at that, very ragged, large mountain range. And then if we continue on up along, we're going to come to one of my favorite spots on the moon. Let me see. There it is. Let me put it dead center. It's almost dead center now in the screen. See that double crater, double center in the center? The top one is Pallas, and the bottom one, I believe, is Murchison. And then up above that, before you get into the terminator, there's some dark, wrinkled, ridge-looking things that are up towards the 1 o'clock position and up near the top. This is the area that we did several videos on, and way back in the 1800s when there was talk of possible life on the moon. This is one of the areas where buildings were suspected and things like that. We talked about this at length in some of my other videos, and it became a worldwide sensation for a while. and they actually had people following this obscure New York newspaper, which was a very small newspaper, and for a few days it had the the highest publication rate of anything out there, because they were doing stories of these so-called Selenites that were supposed to have lived on the moon. And of course that turned out to be a big hoax and not true. And that newspaper went very quickly back to its obscurity. But I find the history of things like that very interesting. As we come farther up along, I think tonight the straight wall is, there's a beautiful, beautiful view of, let's see, I do not have my map on my computer, so I'm going to have to read from a paper map. That huge flat-floored crater, I believe that's Hipparchus, and then above that is Albert Guinness, yeah, and then there's a very nice crater above that with a central peak in it. And that one, let me see. These maps, these paper maps are really pretty tough to read. You know what? I think I gave you some false information. That very flat-floored large crater. No, I've got it now. Yeah, it is Ptolemaeus. That's right, Ptolemaeus. Notice there is a crater pit in that one, over near the 5 o'clock position near the wall on the right-hand side of that crater. There is a crater pit there. The crater above that, that's got that beautiful central peak, little tiny central peak in the center of it. That is Alphonse. That crater was suspected of having activity such as outgassing and all kinds of stuff back in the 60s. And that was a wild ride. I remember being a young amateur at the time and following that very closely. But turned out not to be true. For some reason, people were seeing things that really weren't there. And then the crater right above that, which has got the larger central mountain in it, is Archazella. I believe that's the way you pronounce it. Don't go by my pronunciation of these crater names. I am absolutely terrible at that. Some of these names are really tough. They're Latin, and I stunk in Latin, so in school we used to have it, so don't trust my pronunciation. Moving up here along the Terminator. And yes, there is, and I thought it was going to be a little farther out in the sunlight, but it's not. There is the straight wall, and it's right on, it's just coming into view on the Terminator. See that? It looks like a straight, dark line, and then there's a crater right behind the line. That crater is Bert, and the straight wall is just coming into view. I thought that it would be a little more visible than that, but no, it's not. It's just coming into sunlight tonight, and another hour or two, that's probably going to be a spectacular view. But we'll move on up on along here. This actually is not a bad image for the amount of power we're putting on this 10-inch. Here we're getting into the southern highlands here now. This is really just, there you can see the autofocus doing its thing in and out. It's actually not doing a bad job. It's keeping the focus pretty good. Another interesting crater tonight is going to be the crater Clavius, because I believe that is going to be, okay, there's the very southern end of the moon. So we got to go back down. Yeah, okay. Clavius is not in sunlight yet. See that large crater right in the center of the field? That is, I believe, the crater. Let me get my bearings here. I think that's Maginus. Maginus, yes. And then there's that hollowed out large U-shaped looking object that's over on the left-hand side, probably towards the 5 o'clock area. That is actually Clavius, and you can see the sun is not risen on the floor. It's beginning to pick up the crater rim over there on top. You can see part of the rim sticking up while the rest of it's in shadow. So that's a very high ridge that's catching some early sunlight before the rest of the crater does. And there are a lot of peaks and small craters inside Clavius, which are not in sunlight at all. So we're not going to see anything in there tonight. But all in all, I'm pretty happy with this image that these higher power has given me. I know in the past we talked, or I talked, about craters and how they were formed. And it was a real battle in the 1800s. There was a very, very, very good book written by, let's see, James Nesmith and James Carpenter. Nesmith was a fantastic engineer. He built all kinds of neat equipment, but he had a love of astronomy and built a Cassegrain type telescope where he could sit and look through what was the declination axis of the telescope and stay seated while the telescope followed the moon. Something that some of the professionals used in other observatories later on, and he was the one that came up with the first version of that. And they wrote a book entitled The Moon, Considered as a Planet, a World, and a Satellite. It was published in 1885. And it talked in length about craters and whether they were volcanic or impact and all. And something very interesting came out of that. That problem was never really solved until the 1960s when we were preparing to go to the moon with the Apollo series. And before they attempted a landing with a manned craft, they needed to know, what the surface was made of, how firm was it, and they needed to know what these craters were made of, the material. And it was the first series of probes, the Rangers. They were very rudimentary spacecraft. They had some pretty good cameras in them, but they were just launched towards an area of the moon, and that crater Alphonse, and let me set that up. Right now, it's dead center with the peak in it. Was a target for one of those Rangers, and it just took snapshots of the moon all the way down until the craft actually crashed into the moon, and of course then killed the signal and stopped the photography. But as the craft went in, and they photographed smaller and smaller and smaller craters until it got down to its last few frames, and it was photographing craters that were only 1 or 2 or 3 feet in diameter. And that pretty much solved the mystery, although the Surveyor and Lunar Orbiter, and of course then the Apollo landings settled it for sure. But the Rangers were the first one to really indicate that the craters were impact. And I spent some time, let's zoom in on this crater over here, Ptolemaios. And see that, yeah, let's put it in the center. I'll pick up my story here about craters in a second. Okay, well, we're in the dead center now, and look at that crater pit in Ptolemaios. That's a fairly good-sized crater. That's a lot bigger than what we're going to be going after in the floor of Plato, but not a bad view. It's really a pretty good view. You can see the atmospherics, the scene. It's wavering, but not quite as bad as I thought. I don't know. There's hints of some detail up on the top of that crater also. I see some darker markings on there, but I don't see... I'm looking for other crater pits, and I know there are a couple on this crater floor, but there might be one right there, way up on the top near 11 o'clock. There's something on the floor. I can't tell whether that's a little ridge or whether that's actually a small crater. But notice that the crater at 4 o'clock in Ptolemaeus, notice the white spray out of there. That's probably from impact. That's probably an impact ejecta. But again, we were talking about the craters, and the rangers saying, yeah, they're impact and not volcanic. I mean, as I said, I think I've said before, when's the last time you saw a volcanic crater pit a foot or two across? I mean, they just don't make them in nature, and so why should the moon be any different? So that settled that question. But that brings up a point. I was checking out, I remember in my last video I talked about some other websites, and some that were not too pleasant, but one of these sites, I was looking at it actually last night, and it was a NASA, I don't know if you'd call them a hater, but well, they claim they're lying, and we've never been to the moon and all this stuff, which, of course, I completely disagree on the other side. And one of the things they use when they say we don't go to the moon was, they say, well, they just went out to Arizona and picked up some rocks out in the desert out there, and those are our lunar samples. Well, anybody that knows anything about science and geology and has studied the lunar material that's come back, if you take a rock from the deserts of Arizona and put it under a microscope, and take a lunar sample, a rock from the moon, and put it under another microscope, identical microscope, identical power, you see little tiny crater pits on the lunar samples. Little tiny craters. And of course we don't have that and don't see that on the Earth samples, the ones that come from, if you pick them up from out in the deserts of Arizona. Now, why is that? And it's a very, very simple answer, and it just goes to prove again that yes, we did go to the moon and bring these samples back. If you stand outside at night and you look long enough, you're going to see meteors. A meteor that's, say, the size of a marble will give you a beautiful, real bright fireball. But the average meteor is just so bright. You can see it, but it's not real bright. And they are caused by objects no bigger than a grain of sand. Well, here on Earth, we're going to just kind of look around here as I'm blabbing on. Those little grains of sand just get burned up in the atmosphere and they never reach the ground. Well, on the moon, of course, there's no atmosphere to stop these little tiny grains that in our atmosphere burn up. So they go all the way to the surface, they hit the surface, or the rocks in this case, and they actually pit the rocks. And you just don't get that here on Earth. And I know the people and the conspiracy theorists out there hate that idea and will not accept it, but that's the truth. That's why those lunar samples are different. The pits that are on there are caused by tiny meteorites that would just normally burn up in the Earth's atmosphere. And of course, no atmosphere in the moon. They go all the way to the moon's surface, and they hit these rocks and leave these tiny, even microscopic crater pits at times. There's a nice shot of the crater Proclus, and the large, round, flat-floored Mericrysum is going to be right here. There it is. That's Mericrysum. Another thing that this site was saying, and I don't really understand where these ideas come from, but I mean, I'm not going to put these people down. I said, you have different beliefs, that's fine. But I don't subscribe to them. But one of the reasons I just don't know where it comes from, but they're trying to tell us that the moon's not real, that it's a hologram or something like that. And I'm going, what? I mean, what, are you serious? And yeah, they are. They're serious. And one of the proofs that was given was the last eclipse of the moon, or the last series of eclipses of the moon. It was claimed that they didn't occur at the right time. The timing was off. Excuse me, I'm going to take a drink here of my iced tea. My mouth's getting a little dry here. And I think what's going on there is when a lunar eclipse takes place, a lot of times the newspaper will publish the times of the eclipse. And they'll start the eclipse during when the eclipses start, and when it starts, and the eclipse actually starts in the penumbra of the Earth's shadow, which is the outer part of the shadow. The moon doesn't go into deep eclipse until it hits the umbra, the core of the shadow of the Earth. Now, a penumbral eclipse will go almost completely unnoticed, especially by the general public. They won't even know what's going on. An amateur astronomer like me or others that know the eclipse is going to take place, we don't even see anything going on when the eclipse first starts. It isn't until the penumbral eclipse is almost all the way and through its time, and the Earth is ready to go into the umbra, that we begin to see darkening up on the edge where the moon's going to go into the umbra. So what I think may be happening here, and I could be wrong on this, but what I think is they're taking the time of the penumbral eclipse starting. Say it was supposed to start at 9 p.m. Well, at 9 p.m. you don't see anything happening, because the penumbral eclipse, you just don't see it. It's not visible. It's not noticeable for almost an hour. So they're saying that, well, the eclipse didn't start when it was supposed to. Well, yes, the eclipse did start. It's just the penumbral section of the eclipse, the part of the eclipse, which is very, very subtle, and the average person won't even know what's happening. They won't even notice it. And then once the Earth, of course, hits the penumbrum, the umbra, the center of the Earth shadow, then the darkening takes place. They made a big deal of the blood moon and all that stuff also, and that's nothing more than the sun's rays going through the upper atmosphere of the Earth, and then going on to the moon and striking the moon. Well, when the sun's rays goes through the atmosphere, blue light, having the shortest wavelength, gets filtered out, and it leaves mostly red light that's striking the moon, and that's what colors the moon, that copper red color during a eclipse of the moon. But anyway, I mean, they can have their beliefs and say what they like. I just find it odd that they can actually come out and say that the eclipse did not occur on time, when the eclipses occurred perfectly on time, right when they were supposed to. I got thinking about that when I watched this video last night again, and right away that was the first thing that came to mind. I mean, saying, well, the only thing I can think of is they don't fully understand the mechanics of an eclipse of the moon, and they don't understand that there's a penumbral shadow, which is very subtle, and you're not going to really see it. Very interesting crater here in this shot is, again, we're back to the Alpine Valley, which is up there in the upper right-hand corner at 1 o'clock. Near the center of the screen is the crater Cassini. It's got a lot of nice ridging in it. It's got that crater that's just off center in it. And then let's zoom in. There's ridging in there also, but also there's another crater. Look at that, up near 11 o'clock inside Cassini. So there's another crater we're picking up with this higher power eyepiece that would have gone unnoticed with lower power. So this eyepiece in 2X Barlow it's doing a good job. A little better than I thought. My goal actually tonight is I hope to, after I finish this video, I actually have another camera. I'm using a Logitech, what is it, the Logitech, oh, it's been so long I forgot, the 9C or whatever, the newer Logitech camera. But I have a, that you use just straight out of the box, and you just take the stand off of it, and it's mounted. I think you can see it in some of my videos how I threw mine together, and it's just held over the eyepiece to take these images we're taking. But I also bought an older Logitech 4000 series, and that's only a 640 by 480 chip. But that takes fantastic images, and that's what I use to take my stills, my photographic images, which I process and then end up with a beautiful photograph of the object. And if I have time tonight, I want to throw that camera in when I'm done here and do some imaging. And also the planet Saturn is in Scorpius to my south here, and as usual, I'm sitting in my car at my computer with the telescope controls, and I'm looking to the south about where Saturn will be, and I think I've got a problem because there's a big old fat tree over there, and I'm afraid that Saturn might be in that tree, so I might be out of luck for that tonight too also. But anyway, and look at that, we're 31 minutes in, and again, I'm blabbing on with all kinds of stuff. Again, there's Archimedes. You know, if we back this off a little bit, we're getting a little soft image because of the higher power. There's a nice shadow line there being thrown by the wall, that jagged edge. In fact, if we go back, let me see. If we go back to, where were we? We were over at... let's see, let's get back to the Alpine Valley. Yeah, there's those series of mountains throwing those, they're still standing out pretty good. Those shadows will shorten up and get stubbier looking as the sun angle gets higher, but it's amazing to look at them when they're so close to the Terminator. I mean, look at those, and now go beyond those and go up to about 1 o'clock and go up to the upper right side. Look at the shadowing there. Look at, there's one small peak throwing that one long, thin, triangular shaped shadow. I love those views. They're just fantastic. It just makes you want to drop down to the surface and go for a walk. It's just the feeling I used to get when I was a kid and I first looked in a telescope. I remember one of the first thoughts I ever got when I looked at the moon through a telescope. My friend handed me a 30mm draw tube affair, good quality, and I remember for the first time really looking at the moon and being able to see mountains and craters, and that was the first thing that I thought. I said, I'm thinking to myself, here's another world that if you could get to, you could actually get out and walk around and explore. This was in the 1950s, and little did I know that it was only be 1969, and men would be walking around on that moon. Yeah, that was the heyday back during the moon race, and I enjoyed it all as a young amateur astronomer, and here I am now, 71 years old, and at the end of my career and doing lunar videos. I still do CCD imaging. I'm going to be imaging from this location this summer. I've got a couple targets in mind. I took some real nice ones actually last fall from here. But it takes time to do those images, and I try to do them when the moon's not around, so one doesn't interfere with the other. Color tonight, I've got the color intensity just tweaked, so you can see there's a little bit of color around Archimedes, and you get out here onto the floor, the plains here. And this always shows up. There's The bottom left is Mare Tranquillitatis, and the Sea of Serenity is up to the right, and there's that dividing line, and that Mare Tranquility has got, always has that bluish tinge to it. That is very, very prominent all the time, every time you look at it. It becomes more prominent as the moon gets a little farther on and closer to full phase. I'm going to go ahead and wrap this up pretty quick, guys. I'm just kind of rambling on tonight. Just enjoying this view. It was really a test of this 4.5 millimeter eyepiece with a Barlow. It's doing very well, and we may be able to get a night when Plato is out in the sunlight, and we might be able to check out its floor like we did with the craters in Ptolemaios and pick those out. But unfortunately, I took a look at the long-range forecast, and we're in for a bout of pretty bad weather for quite a few days out. So by that time, the moon's going to be coming close to full phase, and we'll be long past any chance we'll have of getting that Plato and its crater floors. You know, the craters in the floor of Plato at this time. So it may be another time when we can do that. Don't know when it'll be, but I still want to give it a shot. Yeah, this is fairly impressive. The eyepiece is actually doing well. The zoom up is nice. Showing lots and lots of detail here. The straight wall, there's, again, you can begin to see it's starting to become a little more noticeable. See that long black line, and the crater Burt, look like it's got like a pillar underneath it, and then the crater's it's like on top of a cone. And then there's two nice sharp shadows to Burt's left coming off of a mountain range that's actually looks like the handle of a sword when the sun gets up a little higher there on the straight wall. But as nice as this view is, guys, I guess it's about time to put the cork in the bottle here and stop this one. It was fun. I'm very happy. This is the first real test I've had with this 4.5 millimeter eyepiece. I used it one other night, one time, and the images were horrible, and I didn't use the video. But I'm very happy with it tonight. Not the best night for seeing. Look at that wrinkle ridge there. Oh, that's nice. Again, that's right near those shadows we were just talking about. See, I was so taken up by those shadows. That wrinkle ridge, that humped line, curved line in there. Didn't even really notice that when I'm talking about those shadows. But anyway, guys, hope you enjoyed this little tour and my little discussion on crater pits and samples, and explaining. Somebody out there might have heard it. The complaints of some of these people who claim that the last eclipses weren't the way they should be, and they started when they weren't supposed to, or well after. And I think the reason was just what I explained. It was the penumbral eclipse that they were unable to see, so they thought the timing was way off, and it wasn't. But anyway, that's just my side of the story, and you may or may not believe it. And of course, as I always say, that's up to you. But anyway, guys, I'm going to cut it here. Enjoy being back with you again, and we'll be seeing you again shortly with another video, and we'll hopefully be able to go after some more of these crater pits and some of these crater floors.